to, this one is my favorite. I like simplifying radicals. I know that's kind of a pain in the neck, but this one's a really satisfying day. At least for me it is. So let's get going on some more fun math. Of course, I'm Mr. Krause. We'll just call me Mr. K today. You know it stands for key. We'll just K. We'll just K it up. All right, so let me answer this question. Let me ask you this question. If I asked you to solve this, would you all say, oh, okay, x equals 10? But then I would say, okay, but wait a second. Can't x also equal negative 10? Right? I mean, I know what you're doing. You're saying, okay, 10 times 10 is 100. That's true, but isn't negative 10 times negative 10 or negative 10 squared also 100? Okay. And what's the answer to this question? Is the answer to this question just 4? X equals 4? Because if I put a 4 in there, I get 4 plus 2 is 6, and I square that, I get 36, right? But is there another solution? What about negative 6 squared? Isn't negative 6 squared also 36? Right? Wouldn't that make sense? And then what number would make this to be negative? That would be x equals negative 8. So one of the things I think you guys learned, I don't know if you guys learned it in algebra, and if you did, you probably forgot it, that when you're solving problems like this, if in fact you did, when you take the square root, you have to remember to put a plus or minus. So we get x equals plus or minus 10. And we're going to solve this one the same way. Take the square root, I get x plus 2 equals plus or minus. Now what's the square root of 36? It's 6. So I get x plus 2 equals 6 and x plus 2 equals negative 6. And I solve these and I get x equals 4 and x equals negative 8. Well, we're going to play around with that because I don't even know if you guys know how to do that stuff yet, but we're going to work on it. So we're going to talk about inverse operations. You know the inverse operation of addition is subtraction, of multiplication is division, of squared is square root, of square root is squaring something, and of cubed, it's the cube root, and of cube root, we're just going to cube things, right? That's how you undo stuff. So that's what we're going to be doing today. That's what we're going to be doing a lot of today. So we're going to follow 4 simple steps. We're going to get the weird thing alone. We're going to undo the weird thing by doing the opposite operation. We're going to solve for x, and we're going to change. The most important thing, not most important, but one of the things we're going to check for is this thing called extraneous solutions. Sometimes you arrive at a solution using a solid method, but it gives you solutions that don't exist. And that's weird, but we'll play with it, okay? So realize what the weird thing is. In this particular case, the weird thing is the square root of x minus 5. So I would like to get rid of that square root. In order to get rid of that square root, I am going to square both sides. Now, by squaring things, you cause issues because if I square a negative, I get a positive value, which changes the problem dramatically. And that's usually where you end up with those weird extraneous solutions. But I don't think we're going to have that problem in this one. So we get x minus 5 equals 16. Add the 5 over, and I get x equals 21. So in this case, I only have one solution, but I do want to check it. What is the square root of 21 minus 5? Well, why do that? Just do that. Square root of 21 minus 5 is the square root of 16, and that is, in fact, 4. Done. All right. So, again, the rule was, the steps were, get the weird thing alone. So in order to do that, we'll subtract 2. Subtract 2. Now, if you don't do this first step, don't even bother doing the problem because you ain't going to get it right. You're going to screw it all up miserably. Trust me. X plus 3 equals 8. Now we're going to undo the weird thing. So the weird thing is a square root, so we're going to square both sides. So I get x plus 3 equals 64. X equals 61. So let's see if it works. The square root of 61 plus 3 plus 2. Does that equal 10? So this is the square root of 64 plus 2. 8 plus 2 is 10. Check-a-minsky. We got it. All right, let's go. Get the weird thing alone. In this case, the weird thing is that radical, so I'm going to divide both sides by 3. And I get the square root of x minus 4 equals 8. To get rid of that square root, I'm going to square both sides. So I get x minus 4 equals 64, or x equals 68. Checking my work. I'm going to say, okay, does 3. Well, let me show you another way to do this. I can just simply take my calculator, take 8, and store it, control var x, store it into 8, or into x. So I did 8, control var x, press enter, and then I just type the left side of the equation. And this is a nice thing about this calculator. 3 square roots of x minus 4. Oops, that's not going to work. I think our answer was 68, wasn't it? Our answer is 68. So we're going to put 68 stored into x. And then we're going to type in our left side, which is 3, x minus 4, and we got 24, and we want it to be 24. Of course, you got to store the right answer in for that to work. All right, let's get the weird thing alone. And you solve this like you would solve it if you had 2x minus 4 equals 8. You'd bring the 4 over and then divide by 2. You're going to solve that the same way. This is our weird thing. And we're going to get that weird thing all by itself. So the first thing we're going to do is add the 4 over. So I get 2 square roots of x plus 3 equals 12. I don't need to show the adding. Then we're going to divide both sides by 2. So we get the square root of x plus 3 equals 6. Now I want to undo this radical. Square both sides. Square both sides. I get x plus 3 equals 36. Or x equals 33. So that's what I think is the answer. Let's go check. So 33, control var x, press enter. And then type in the left side. Type it exactly as it appears. Square roots of x plus 3 minus 4. And we're hoping this turns out to be 8. 8. Done. Problem's over. All right, guys. Now it starts getting a little, now it starts getting a little bit trickier. Now it's going to get a little trickier because this thing's all by itself. So I have to square this side, but I also have to square this side. Now, if you can imagine, we're going to square this x plus 1. That's really x plus 1 times x plus 1 equals 7x plus 15. Right? Squaring this side just gets rid of the radical. Now, squaring the left side gives us a quadratic that we're going to end up having to, oh, you said it, factor. So what do we got? We got x squared plus 2x plus 1 equals 7x plus 15. Everything goes to the left, so we're subtracting 7x, subtracting 15. So I get x squared minus 5x minus 14 equals 0. X minus 7, x plus 2. So I have two answers in this case. X equals 7 and x equals negative 2. Those are my two solutions. I'm not sure if they're both going to work or not. And as a matter of fact, if you plug in negative 2, what's negative 2 plus 1? Negative 1. Do you think you're going to get negative 1 when you take the square root of a radical? You ain't. You ain't. So let's do this. Oh, my calculator's going to do all kinds of funky stuff. Let's just do it in our head now. So we're going to plug in the 7. So 7 plus 1, that's 8. Does that equal the square root of 7 times 7 plus 15? That's 49 plus 15, which is 64. The square root of 64 is 8. Now let's plug in the negative 1. Let's plug in the negative 2. Negative 2 plus 1 is negative 1. The square root of 7 times negative 1 plus 15 is equal to the square root of 1, which is just 1. And 1 does not equal negative 1. So there we go. That is what we call an extraneous solution. So my answer to this question is simply just 7. And I forgot to tell you, I really want you to tell me the answers like this. 68. Put those answers in there like that. Make those answers look sharp. 33. All right, let's do this next one. So what we got to do on this next one is get the weird thing alone. So we're going to move the 1 over. So we end up with, these problems are hard to write. I remember when I was writing these this summer. These are hard to come up with. So we're going to square both sides. But I know that just means write this twice. So on this side I get 2x minus 2 equals x squared minus x, that's minus 2x, plus 1. Now be careful when you move stuff over. We're going to subtract 2x over, and we're going to add 2 over. So I get 0 equals x squared minus 4x minus plus 3. Factor this thing. X minus 3, x minus 1. I'm not waiting for you to factor. By now you should be pretty good at factoring. So I get 2 answers. X equals 3 and x equals 1. And I got to verify that they are both, in fact, the correct answers. So I'm going to check them very quickly. The square root of 2 times 3 minus 2 plus 1, does that equal 3? Well, this is 6 minus 2, which is 4. The square root of 4 is 2, so 2 plus 1 equals 3. Perfect. So 3 works. Now let's try 1. Two minus 2 is 0. The square root of 0 is 0. 0 plus 1 is 1. Yeah, so both of them work. So the answer to this one is 1 and 3. And I think that's behind my head, so sorry about that. All right, so on this one, we're going to do the same thing. Cube root of x equals 8, right? Because we're going to add the 9 over. To get rid of a cube root, I cube both things. And so I get x equals 512. If you checked it, it works. All right, let's get this weird thing alone. We're going to divide both sides by 2. Shaboom, shaboom, 2, shaboom, 2. So I get cube root of x minus 3 equals 2. We're going to cube both sides. Remember, 2 cubed is not 6, it's 8. So I end up with x minus 3 equals 8. Add the 3 over, I get x equals 11. Now you should check this. 2 cube roots of 11 minus 3, does that equal 4? 11 minus 3 is 8, so that's 2 times the cube root of 8. Does it equal 4? The cube root of 8 is 2, so 2 times 2 is, in fact, 4. That was behind my head. Let me slide that forward up a little bit. All right, let's do some, oh, I remember this stuff. Okay, let's go. I love this stuff. All right, we're going to deal with rational exponents. Rational exponents is everybody's favorite word, fractions. Fractional exponents. Now, I want you not to be afraid of these at all, because these will be one of the easiest things you do all year. Promise. So we've said that if we square a square root, they cancel each other out to give you 1. Well, why is that? Why is that? Let's see. So, the reason that is true is because a square root is the same as x to the 1/2. Now, that's something new. So, x to the 1/2 power is really equal to the square root of x. Now later on we're going to find out that x to the 1/3 is the same as the cube root of x. We're going to deal a lot with these things. We're going to deal with a lot with them. Actually, we're going to deal a lot with them right now. Let's see. So why does this work? Well, because these things mean the same thing. This and this is the same thing, because I'm not saying this very well. This is a definition. This is just something you got to know, that a square root has an exponent of 1/2. Well, what do we do when we do exponents raised to exponents? We multiply them. So what is 1/2 times 2? It's 1. Now, so in general, here's how we're going to handle rational exponents. If you have, and I don't like the way this is written, if you have a rational exponent as a over b, if you want to get rid of that a over b, what you're going to do is you're going to raise it to the reciprocal. Reciprocal. Having a hard time spelling reciprocal. Reciprocal. The reciprocal. Raise it to the reciprocal. Why? Because a over b times b over a is simply just 1. In other words, it simply just equals x. Let's play around with this and let's see if you can figure this out. Here's how it's going to work. We're going to get the weird thing alone. Now, it should be obvious that this is the weird thing. We want to get that thing all by itself. So I'm going to rewrite it. I'm going to add the 1 over, so I get x plus 2 to the 3/4 is equal to 8. Now, what we're going to do is we're going to get rid of, I don't like this 4, we're going to get rid of that 3/4. I got to pause for just 1 second. Okay, I'm back, sorry. Then we're going to add this 1 over, so we get 8. All right, so now, and I don't like where I put the equal sign. That's what I was trying to get rid of before, actually. I wanted to put the equal sign a little bit over, and you'll see why in a second. I'll leave a little gap there. What we want to do is undo the weird thing. The rules are still going to be the same. We want to undo the weird thing. Well, the weird thing is that stupid fractional exponent. So what we're going to do is we're going to take this whole thing, and we're going to raise it to the reciprocal. Please say those words. We're going to raise it to the reciprocal. We're going to raise it to the 4/3. So, some of the things we haven't talked about yet is this thing on the denominator, that's the root. This thing up here is the exponent. So, you can do this in your head if you want to, but when you raise something to a rational exponent, the denominator is actually the root. The numerator is actually the exponent. So, you'll see what I'm talking about in a second. 4/3 times 3/4, they cancel each other out, and I'm left with x plus 2 equals. Now, what this really means right here is the cube root of 8 to the 4th power. They mean the same thing. The denominator is the root. The numerator is the exponent. Now, so I think you should be able to do this in your head. What is the cube root of 8? It's 2. 2 to the 4th power is 16. Subtract the 2 over, and I get x equals 14. Now, again, I would just use the dumb machine to check this thing. 14, control bar x, press enter, and then x plus 2. Raised to the 3/4. 3 divided by 4 minus 1 should be 7. And 7 it is. Okay, so keep going. We're going to keep playing with this. First things first, we're going to divide by 3. Divide by 3. So I get x to the 3/2 equals 125. Now we are going to raise the fraction to the reciprocal, because we don't like it, 2/3. 2/3. This is the root. This is the exponent or power. So what is the cube root? These just cancel. What is the cube root of 125? It's 5. 5. So the cube root of 125 is 5. 5 squared is 25. And if you check that one, it works out fine. All right. This one already has the weird thing alone, so we're just going to simply raise it to the reciprocal. which is 2/5. And we're going to raise this to the reciprocal, which is 2/5. So this gives me x plus 3 equals. So the fifth root of 32, come on now, the fifth root of 32, it's not like 1.6374, it's 2. It's 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the fifth root of 32 is 2. 2 squared is 4. Subtract 1, or subtract the 3, and I get x equals 1. Now, why is that? Let's check that out. Let's check this one. 1 plus 3 to the 5 halves. We want that to be 32. Well, this is really 4 to the 5 halves. Does that equal 32? Well, remember, if the denominator is the root and we got a 2, that means the square root. What is the square root of 4? 2. 2 to the 5th power, 32. All right, let's do a little bit of negatives. Subtract, divide by -3. Divide by -3. Oh, we made this easy. So I get x to the 3/4 equals positive 27. Now we're going to raise it to the reciprocal. Please do not say multiply. Now what we do with exponents is multiply, and those get multiplied together, which is why they cancel. But it's raising it to the reciprocal, 4/3. So x equals, the cube root of 27 is 3. 3 to the 4th power is 81. All right, this one's already set up for us. Let's raise it to the reciprocal, which is 3/4. Raise it to the reciprocal, which is 3/4. So what do we got? We got x minus 5 equals, the 4th root of 81 is 3. 3 cubed is 27. Add the 5 over, and I get x equals 32. All right, last one. This is as complicated as they get. They don't get any harder than this. This will be a 2 or 4 point question on your exam. So don't even sweat this stuff out. We're going to subtract the 3 over. We get x plus 2 to the 2/3 equals 4. This will be at least a 2 point, probably a 4 point question. Raise it to the reciprocal. Raise it to the reciprocal. So I get x plus 2, because if you raise it to the reciprocal, they cancel, equals. What's the square root of 4? 2. 2 cubed is 8. Now, if you want, you can just come over to the calculator and just put this in your calculator. It will tell you. Like, if you're stressing about that, don't worry about it. Just put 3 divided by 2 in your calculator. It'll tell you it's 8. The calculator will do it for you. And I end up with x equals 6. And I probably should be checking those. That one works. The big ones that have to be checked, quite honestly, are the ones that usually come up with 2 solutions. So these ones like this one that usually come up with 2 solutions, you'll have to check, okay? All right, let's go get started on our homework. All right, bye.